Today we are taking a look at similar triangles, chapter 13, page 137. So what do we mean by a similar triangle, and how is this different from a congruent triangle? I will explain this by making use of this buddy over here. So if we look at this picture, and I take my mouse, put it on this corner, and I pull it bigger or smaller, he stays in the same proportion. So it's the same picture, just bigger or smaller. But what happens if I take this picture and I make it bigger by pulling on this side? What is happening to his face now? It is distorted. Or I take it over here. He's got a long face. It's no longer in proportion. So it's no longer similar. Whereas with the first one, it is still similar, even though I make it bigger or smaller. That now brings us to similar triangles then. So with congruency, we had 4 cases. With similar triangles, we only have 2 cases. The first is to show that they are equiangular, and the second is their corresponding sides are in proportion. What do I mean by proportion? It's what I did with the first picture. If I pull it so that the picture remains the same, just bigger or smaller. Okay, so how do we go about proving that? So the first one, equiangular, is very easy. It means 3 angles that are all the same. Now don't confuse this with congruency, where we had angle, angle, side. For similarity, we need all 3 angles to be the same. So let's take a look at this triangle. Okay, so our first triangle is ABC, and our second triangle is ADE. So the one is the whole blue part and the other one's the red part. So we know both of them have this angle. So angle A is a common angle. Then we see that this and this is both 180 degrees, 18 degrees. We also know this because it is corresponding angles. So we have another angle that's equal, and the same goes for these 2 angles. So it's indicated, but we also know that it is corresponding angles. Therefore, we have 3 angles that's exactly the same size, and that means these 2 triangles are similar. Now let's look at our second reason. Corresponding sides are in proportion. Okay, so now that we understand it from the picture, what does it mean when we look at triangles? That means if we're going to take the sides of the 2 and we divide it, it's going to give us the same fraction as an answer. Okay, what exactly am I saying? I'm moving down here. If we take the longest side for the one triangle and we divide it by the shorter side. So we are taking ABC, this triangle, and the longest side for ABC is 60 centimeters. We divide it by the longest side for the second triangle, which is 45 centimeters. And we say this is equal to the longest side for this triangle, 80, divided by the longest side for this one, 60. If we get the same fraction, that means they are in proportion. We could also say the longest side and divided by the longest side equal to this side divided by this side. So here we go. The longest side divided by the longest side equals the middle side divided by the middle side equals the shortest side divided by the shortest side. And all of them gives us 4/3. All 3 of them, when we write them in their simplest form, will give us 4/3. And therefore, we know that it is in the same proportion. And therefore, we can say that it is similar triangles.